Welcome to Chapter 3, Section 1, Graphing Systems of Equations. What we're going to learn today in this lesson is to solve a system by graphing. Some of the things we're going to learn: system of equations, a linear system, independent system, a dependent system, and an inconsistent system. We'll learn all that here in just a little bit. First thing, let's look. A system of equations is nothing more than a set of two or more equations that use the same variables. In a graph, each of the equations in a system is a line. This system that we're seeing right here is a linear equation. A brace or a bracket is used to keep the equations of a system together. Okay? A solution of a system of equations is a set of values or for the variables that make all the equations true. You can solve some linear equations by graphing. The point where both or all the graphs intersect represents all the possible solutions. Okay, so let's just jump into it. Solve by graphing. We have two equations. First one is x plus 2y equals negative 7. So let's solve for this one. Okay, let's get it in slope-intercept form. That seems to be the easiest way for us to do this. So we're going to subtract x on each side of the equation. So now we're going to get 2y equals negative x minus 7. Divide everything by 2. So we're going to divide every term by 2. And we're going to get y equals negative 1/2 x minus 3.5. So that's the first equation. Okay? We can plot that in just a second. We can figure it out. So let's go to the second equation we were given. Okay, that equation is 2x minus 3y equals 0. So we're just going to add 3y to each side. So we're going to get 2x equals 3y. Divide each side by 3. Or we can go get y equals 2 over 3x. You see, all I did was divide each side by 3, and we have our equation set. Okay, let's graph the red one first. Okay, I have a y-intercept of negative 3.5. I have a slope of 1 over 2, negative 1 over 2. So that's up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay, we can draw that line. Now let's graph the purple one. I have a y-intercept of 0 and a slope of 3 over 2. So down 3 over 2. Or sorry, up 2 over 3. Up 2 over 3. So what do you notice? We share a point. Okay, we can graph our lines if we need to, just to show. So let's do that. There's my one equation. There's the other one. So you're going to see it intersects right there at negative 3 comma negative 2. So that is our solution for those two linear equations. Again, graphing isn't necessarily the best way to solve two variable equations, but it is a good way. It works. Okay. Now we can classify a system of two linear equations by the number of solutions. Okay, what this means is a system that has a unique solution, as an example of 1 and 2 that we worked, is considered an independent system. That means they have intersecting lines. However, not every system has a unique solution. Okay, a dependent solution or a dependent system does not have a unique solution. An inconsistent system is a system that has no solution. So let's look at how that affects our linear equations. All right, so if we got linear systems, an intersecting line, two lines that intersect each other, that is one solution that is independent. If we have a solution set that is the same line, it is dependent with no unique solutions. In the last examples, if we have two equations or two linear systems that are parallel, they never intersect, then we have no solution. It's inconsistent. So independent intersects one time, dependent, it's the same line, and inconsistent means they're parallel. So you can classify this system of equations without even graphing. You can just compare the slope and the y-intercept. So again, setting your equation in slope-intercept form can tell you if it's dependent, independent, or inconsistent. So let's take a look. So we're given two equations, okay? We're given the first equation, y equals 2x plus 3. That's already in slope-intercept form. My slope in this one is 2. My y-intercept is 3. My second equation is negative 2x plus y equals 1. So let's get it in slope-intercept form. So we're going to add 2x to each side. So we're going to get y equals 2x plus 1. So my m value is 2. My b value is 1. So what do we notice? Well, we notice our slopes are the same. So that means it's either going to be inconsistent or dependent. And our b values are different. So we're going to find out these are parallel lines. They're never going to run. So there is no solution. There is no solution, and the system is inconsistent. So no solution's inconsistent. If it's the same line, it's consistent. And if it intersects, it's independent. Okay? Let's go on to the next example. Solve by graphing. 2x plus y equals 5. Okay? And negative x plus y equals 2. Let's take the first one. Let's go 2x plus y equals 5. So we're going to subtract 2x to each side. So that equation is going to be y equals negative 2x plus 5. I can graph that. I have a y-intercept of 5 and a slope of negative 2. So that means down 2, 1 to the right. Down 2, 1 to the right. Down 2, 1 to the right. So I have that equation. I can plot that in just a second. Now, let's do the next one. We'll do negative x plus 2, or plus y equals 2. So we're going to add x to each side. So we're going to get y equals x plus 2. Well, my y-intercept is 2, and I have a slope of 1. So what do you notice? Okay, you notice we intersect at the spot 1, 3. Let's draw our line so we can see that even better. So there we have it. So there was my two lines right there, intersect at 1, 3. So the answer would be B. Okay, next example. Without graphing, classify. Okay, the first one's already done. So the first one, y equals 2x plus 3. We have a slope of 2 and a y-intercept of 3. Okay, let's work the second one. I got negative 4x plus 2y equals 6. Let's add 4x to each side. So we get 2y equals 4x plus 6. Divide everything by 2. So I'm going to get y equals 2x plus 3. I have the exact same equation. Okay, so since the slope's the same and the b value is the same, again, m would be 2 and b would be 3, it would be dependent. Independent means it intersects, dependent's the same line, and inconsistent means parallel. All right, next look, here we go. Without graphing, classify. The first one is x minus y equals 5. Let's subtract x to each side. Negative y equals negative x plus 5. Divide each side by negative 1. y is going to equal x minus 5. So I have a slope of 1 and a y-intercept of negative 5. Okay, let's look at the second equation. I have y plus 3 equals 2x, so we're going to subtract 3 to each side. I get y equals 2x minus 3. There's my equation. I have a slope of 2 and I have a y-intercept of negative 3. Okay, since my slopes are different, I know they're going to intersect, so we're going to have an independent or one solution. Okay, well, that was the lesson on how to graph to solve equations. I hope that helped.